This lesson is on exponents and logarithms. First of all, we need to understand what the definition of a logarithm is. There will be cases where you're going to get an exponential function, like that one, b to the x power equals a. Then we will have to rewrite it. First thing we need to know is that you will have the b, which is the base. Then we're going to have a, which is the argument, and it's going to be equal to x, which is the exponent. Now, how do you read this? You read it log base b of a equals x. Why do we have them? Why do we use these logarithms? It is to isolate the exponents. Now we're going to do a couple examples, a through n, where we'll be rewriting the exponential equation in logarithmic form, or vice versa, writing the logarithmic into exponential. If we look at the first one, 7 squared equals to 49, we see that b would be the 7, 2 is the exponent, and 49 is the argument. So when we rewrite it, it would be log base 7 of 49 is equal to 2. Next one, 3 to the 5th power equals 243. The base is 3, the exponent is 5, and the argument is 243. So this becomes log 3 of 243 equals to 5. Next one is 6 to the negative 2 equals 136. Now, 6 is your base, the negative 2 is your exponent, and the 136 is your argument. So when we rewrite this, it becomes log of base 6 of 136 equals to negative 2. D, 9 to the power of 1.5 equals 27. When we rewrite this, it becomes log 9 of 27 equals to 1.5. E, 4 to the 9th power is equal to x. So when we rewrite this, is log base 4 of x is equal to 9. Now moving over to the right column, we see the f, 2 to the x power is equal to 20. So this becomes log of base 2 of 20 is equal to x. G, log to the x power equals 32 will become log base 8 of 32 is equal to x. So these problems are going from exponential to logarithmic. Now when we do h through n, we will be doing the x from logarithmic to exponential. If we look at the first logarithmic, right there, it's log base 2 of 64 is equal to x. Now this now becomes 2 to the x power equals to 64. Next one, log base x of 64 equals to 2. This one becomes x squared equals to 64. And if we actually had to work out this problem, what to the square gives you 64? Hopefully, your answer was 8. 8 squared is 64. J, log of 64, base 64 of x is equal to 2. When we write this, it's 64 squared equals to x. Now, on k through n, these all have the common base of 10. When the base is not given, it is understood to be a 10. So the first one is just base 10 squared equals to 100. Now L would be base 10 negative 3 equals to x. And M would be 10 to the fourth power equals to 2000. And n would be 10 to the x power equals to 1/10. When we practice rewriting a log, there could be three different kinds of scenarios. The first one is when x is the exponent. It would be rewritten, like in this problem, 2x equals to 32. Then by trial and error, we need to figure out 2 to the what power equals 32. And of course, according to the example, 2 to the fifth power is the only one that would give you 32. So then x would be 5. Now when x is the base, it becomes x squared equals to 32. Now, how can we get rid of the 2? Well, by doing the reciprocal of the power. The reciprocal of 2 is 1/2, and that's what square root stands for. So the square root of 32 would be the answer to x. When x is the answer or argument, then it would be 32 to the second power equals to the argument. So all you have to do is just plug it into your calculator, 32 times 32, which gives you 1024. So these are the three different scenarios, so we need to identify which one is for each one. So if we see letter A, log base B of x is equal to 3, we have the x as the answer or argument. So it's going to be like the third scenario up on the top. So this is the way we would rewrite it. 9 to the third power equals to x. That would mean 9 times 9 times 9, which is 729. So that would just let us know that x is 729. B is log base 3 of 9 equals to x. And this time, x is the exponent. So it would be like the first scenario. When we rewrite, it becomes 3 to the x power equals to 9. Now, what power would x have to be in order for it to be 9? Well, let's try a couple. 3 to the 1 is 3. 3 to the second is 9. That would have to mean that x is 2. Now, let's look at C. Log base x of 64 equals to 3. In this case, x is the base, so it's like the middle problem. That would become x to the third power equals 64. Like we said, we're going to need the reciprocal. So the reciprocal of 3 is 1/3. In order to solve for x, we will have to raise each of these sides of the equal sign to the power of 1/3. On the left side, that 3 and that 1/3 cancels, but on the right side, we still need to plug that into the calculator. 64 raised to the 1/3 power, which will give us 4. And isn't it true that 4 times 4 is 16? 16 times 4 is 64. Moving on to example D. Log base 7 of x equals to 4. We rewrite this as 7 to the fourth power is equal to x. This is the one where we actually have to work it out. Now 7 to the fourth is 7 times 7 times 7 times 7, which is equal to 2,401. That would be your x. Letter G, log base 9 of 181 equals to x. Since x is the exponent, we will rewrite it as n to the x power equals to 1 over 81. Now we know that 9 to the 1 power is 9, and 9 to the second power is 81. That would mean that 9 to the negative 2 power would be 1 over 81. Anytime that you have a fraction like this, it would just be a negative of the exponent. That would give you the number. Letter H. So the answer would be x equals negative 2. For h, we will have to remember that when there's no base, it's understood to be a 10. So this becomes 10 to the x power equals 10,000. And if you remember from the notes, we already did a problem like this. 10 to the first power, 10, 10 to the second, 100, 10 to the third, 1,000, 10 to the fourth would give us that 10,000. So that would mean that x is equal to 4.